Hey everyone, welcome back to the Kafka series. So far, we have covered Kafka concepts and internals. And in this video, we will put all of that into real practice. We will build a Kafka producer and consumer using core Java Kafka APIs. And later, we will see how the same thing is simplified using Spring Boot. This will help you really understand message flow, polling and offsets before we move to the Spring Boot version later. Without wasting time, let's get started. The goal of this video is set up a Kafka project and then developing a simple producer consumer application to understand how it works. There are certain properties which we did not use when we played with console producer and console consumer. There are a lot of things hidden for us actually, but by developing a simple Java application, we can see this much better now. Also, we did not talk about acknowledgement concept earlier. Now we can talk about that as well. We can create a consumer group, we can have multiple instances of consumer applications and see how things are working. And partition assignment and rebalancing strategies. How it works when the consumer starts, when the consumer dies, when you have multiple partitions. So how multiple things are working. Here we can see this much better. So let's create a Spring Boot Java project, and firstly we will create producer consumer application with core Java Kafka APIs, and then we can leverage the same project to create a Spring Boot application on top of it. Let's go to Spring Initializer to create a project. I just need to go start.spring.io, right? So if you go to this is the kind of mechanism to create Spring Boot projects, right? Let's add dependencies right away. What all dependencies we need? Firstly, we need Spring Web, right? This is one of the dependencies. Then we need Kafka. Then if you see over here, there are two Kafka, Spring for Apache Kafka and Spring for Apache Kafka streams, right? We need to add Spring for Apache Kafka. The Kafka streams we will see later in the separate course, all right? So then we can add one more dependencies as Lombok. So if you see, there are three dependencies which we have added. Now let's change the group name as com.suhail. And what should be the artifact? Let's say the Kafka playground is my artifact name, and the project would be kind of Maven. The version would be Maven. The Spring Boot version would be 4.0.2, and the Java version which we'll be using is 17. Right, let's explore and see this. That's how the pom.xml would look like. That is the artifact name. And then we have added WebMVC, the Kafka, and it has included the compiler plugin, Lombok. That's all, right? So what we can do is we can just escape and we can create the Kafka Playground application. Now that has been downloaded to my downloads folder. Let's import into the IntelliJ. What I will do is IntelliJ, right? I'll add downloads and the Kafka Playground. Now the project has been imported into the IntelliJ IDE. You can use any IDE, not the IntelliJ. I'm much familiar with IntelliJ. I'm using this same, but you can use Eclipse or any whatever you are using, right? So if you see the pom.xml group ID which we created onto the Spring Starter Initializer, the same group ID has been there, and we added the three dependencies: the Kafka, Lombok, and the Spring Web, right? So all these dependencies have been added. Now the guys who are aware of the Spring Boot application, how it creates behind the scenes, so this is the standard template how the Spring Boot creates the application, right? So the guys who are doesn't know about why and how Spring Boot creates this application behind the scenes, don't worry about that. We'll cover that later. But in this video, the goal is to set up a producer consumer application to see and connect with Kafka how the messages are being flowing. Let's get started on that part quickly, right? So what I'll do is, since this is our day one of the coding part in the Kafka series, I'll create the package like day wise, right? So what I'll do is I'll just create day 01 is one package, and in this package what I'll do is I'll just create the class with, let's assume, the day 01 Kafka consumer. Let's create the main method. as of now, we are just trying to understand the things, how it works behind the scenes, right? When we use Spring, we don't need these main methods, right? There is only one main application, that is the main application is this one, whichever Spring has created, right? But in reality, you won't see this main classes anywhere in the Spring Boot project, right? So this is just for demonstration. We are just trying to understand how things are working behind the scenes. So this class is about Kafka Consumer. So if you see the Kafka Consumer, this is coming from org.apache.kafka.clients library, right? So this library is open source and it has been injected into the Spring Boot Starter Kafka project, right? So the person who doesn't want to use Spring Boot application to connect with Kafka and do all the messaging flow, they can just use the org Apache Kafka clients library. That would also solve the purpose, right? The Spring Boot Kafka starter is just a wrapper on top of this library. Got it? So what we can use is, in this video, as I earlier mentioned, we need to use the simple core Java APIs. So that is what we will use. Later we will cover Spring Boot version, right? So I can use the same Kafka Consumer. Now I have the Kafka Consumer. But when we demoed Kafka Console-Consumer, what did we do? Let's flashback. Let's go to the GitHub repository, which I have already created. In this repository, I have mentioned all the commands. Let's go to this commands.txt. If you see the Kafka Console-Consumer, right, we need to provide the bootstrap server to connect with Kafka. Then we need the topic, the Kafka Console-Consumer, assuming the topic is already there. And there will be some producer who is producing some values onto this topic. And then we have the group, the consumer group. And then also we do have the from beginning. So these are the few attributes which we need to provide when we want to consume events from any of the topic, right? So let's provide that. So if you see the Kafka consumer constructor, it accepts the map, it accepts the properties. So for what purpose it is? So how we can provide the attributes to connect with Kafka, to provide the consumer group, how we can do that? We need to assign into a particular map or into a properties, and then we can pass these properties into this Kafka constructor. Let's do that quickly. So what we'll do is properties, we have created the properties, right? Now what we need to do? We need to provide the bootstrap servers, right? So for that, what we'll do is props.put consumer config dot. So this is the consumer config class is already there, which provides all the consumer related properties, right? So here what we need is bootstrap server. We have the bootstrap server config. So we can provide this. We need to provide the value for the bootstrap servers through which we would connect to Kafka. So we can provide this localhost 9092, right? If you have multiple servers acting as a bootstrap servers, you can provide the values as comma separated. For example, localhost 9093, 9094, right? So that's how you can do that. But as of now, since we have a single node Kafka cluster, what we can do is we can just provide single entry. If you see the consumer config, right? So it has lot of properties, the group ID, right? The bootstrap servers, right? Enable auto commit, max poll records, we have already seen, right? The max poll records. So it has 20, 30, 40 properties are already there, right? So how the flow is actually, the producer is producing the message onto the Kafka broker. There is a consumer who would be consuming the message from the Kafka broker. That's how it is, right? So there are three components involved: producer, Kafka broker, and consumer. The consumer has the consumer config, right? Similar to consumer, we do have the producer configurations as well, right? So the producer configuration is different, and similarly to this producer, we do have the broker configuration as well, right? So we do have different configurations available for different components. Let's provide other configurations, right? Let's go to the GitHub. Then what we need? We need the consumer group. For that, what I will do is props.put, right? the consumer config dot group ID, right? So we can do that group ID, and here we need to provide the value, right? So as of now, I can just provide the play group as the one value. Let's say this is my consumer group for playing with Kafka. The next property we want to give is, this is something which we never discuss when we use Kafka Console Consumer, but this is very important. Let's discuss that. So if you see, I have taken this picture from my earlier videos, right? So this is the publisher, this is the Kafka server, these are the Kafka consumer groups, and these are the consumer in this consumer group, right? Now, if you see what the consumers are going to do, the consumers are going to receive the event, right? But as you know, Kafka stores everything in binary format, right? We have already discussed that Kafka has byte array, everything is in binary format, right? But when we are coding into a Java application, the Java library provides us a provision where we can specify what kind of data this consumer is going to receive. Whether it is a string type, whether it is a number type, some other type, we can mention it. So there are two deserializers at the consumer level. The first one is the key deserializer and the other is value deserializer. What the value deserializer is, the value is actually the payload. What data it is receiving, right? And the key deserializer is when we publish the data onto the Kafka broker, we publish with a partition key, what data type of key it is, right? And what data type of value it is. So these are two different deserializers which we can provide. Let's use that in our Java application. Props dot put dot key deserializer class config, right? So here what we can do is, I can just provide string deserializer. You need to just pick up the correct deserializer from the Apache Kafka serialization library, right? So we use string deserializer dot class. So this is serializer we define for key, and similar to this we need to define for value, right? So we can just provide the value as well. If you see, deserializers are required at the consumer level, but at the producer level, when the producer is publishing the message onto the Kafka broker, at that point of time we do need serializer. Let's go to this Apache Kafka documentation. So it has lot of different configs, right? So if you see the producer configs, it has the key serializer, value serializer. So there are different properties for each and everything, right? The producer has different configurations, the bootstrap servers, the buffer memory, right? The other things. And if you see the group consumer configurations, you can see the key deserializer, value deserializer, bootstrap servers, group ID. There are a lot of the consumer configurations, and there are broker configurations as well. For example, for how many days we want to keep the retention, that right, retention of the messages, we have already discussed that. So these are something which are basically at the broker level. So there are broker configurations, right? So all the configurations are different. Now let's move back to the Kafka application. Now in this constructor, what we need to do is we need to provide the properties. Let's add one more property I forgot to add, that is the props.put. There is one property called enable auto commit config, right? So if you see, this property is by default true. What we can do is we can just mark it as false, because we don't want message to be auto committed as and when the Kafka consumer is reading the message, right? We'll do that manually from the Java application. Now we have the Kafka consumer ready, but still we have to subscribe to a topic. How we can do that? So for that, what Kafka consumer provides is we need to just call the subscribe method, right? So if you see in the subscribe method, we need to provide the pattern, or we need to provide the list of topics. So as of now, I can just use the simple list, right? Let's rename this the order events. Now Kafka consumer has everything, all the information. Now this has to get the events from the Kafka broker. For this, since we already know Kafka follows pull-based approach, that means consumer has to go to Kafka broker and ask, please give me new messages, something like that, right? So for that, what it provides is it provides the consumer.poll, and in the poll we can specify the timeout, right? When this poll request should be timeout, right? So that the next call should go to the Kafka broker to fetch the new messages, right? So we can provide the duration of, let's say, 1 second. 1000 milliseconds is equal to 1 second. But this is just a one call, right? But we have to go to Kafka broker again and again repeatedly, right, to fetch all the new messages. So for this, what we need to do is we need to introduce this into a while loop. So if you see, what it provides is it provides the consumer records. Let's say it provides, as of now, string. Why it is giving a yellow line? Let me fix this. So okay, I got the problem. So it is not generic. So here also we can provide the string. So it means the partition key is also string, the value is also string, whatever we are receiving in an event. Now it looks okay, the records are there. So what I'll do is I'll just print out the records. I would like to add logging framework. To print this, what we can do is we can add the log to this. So what I can do here is quickly create the logback.xml, right? If you have worked on Spring Boot Java application, so if we have the logback XML in the resources folder, right, the Spring Boot application automatically picks up this logging framework and gives us prints the logs accordingly. So for this, what logback configuration I need to provide? So I can go quickly to this and I can just copy this configuration. That is the logback website from where I'm just copying this configuration, right? So I can come back onto this Spring Boot and here I can just provide the info, right? So it has the appender, the console appender, right? So for all the console logs, what we need to provide is we need to provide the log, right? So in this same consumer, what I can do now is private, right, then logger slf4j, right, log is equal to logger factory, right? Now we can print out the logs, records dot for each log dot info, then I'll just do key and then I'll just provide the value. Let me resize the IntelliJ so that you can see it better. So if you see, we are just iterating to over all the records. We are just logging in the key and the value. So what it provides the method to access the value and the key. So it provides the key method and the value method through which we can get all the things. But if you see, there are other methods as well. For example, record dot, right? So delivery count, offset, partition, from which partition we have received the message, the serialized key size, the timestamp, the topic. So it provides a lot of other methods, but as of now we are just printing the key and the value. Now we need to handle few of the cases, because if we are facing any exception, we need to close this Kafka consumer. Why it is giving the yellow line? Because it is not being used appropriately. I can just add the try catch block dot error, right? So we can just log this exception, and also let's provide the finally block, and in the finally block what we'll do is consumer dot close. That's all we need to provide. Now we are good with this. We have Kafka consumer ready. It is calling the Kafka broker repeatedly after every 1 second, because this poll request is timing out in 1 second. So implicitly it is sending the request to the Kafka broker every 1 second, and as and when we are receiving the records, we are just printing the key and the value. Now let's open the Kafka console, let's create the Kafka topic, and let's run the consumer application. Let's open the Kafka console. So firstly, I'll just see whether my Kafka container is running or not. For if you guys are new and don't know how to do this, I have published a detailed video on Kafka setup on my YouTube channel. Please refer to that. So I have the two containers running, Redis and the Kafka. So what I'll do is I'll just go inside the Kafka and do the bash, right? So you know, right, all the commands. So the Kafka, let's go to the bin folder. Let's see what all topics we have, right? So Kafka topics.sh, we need to provide the bootstrap server, right? And the bootstrap server is localhost 9092, and we can provide the list. We want to list out what all topics are there. So if you see, the order events are already there. Let's start from scratch. Let's delete this topic, right? And let's provide the delete. I just want to delete this topic. Let's run the list command again and see. Now the topic is no more there. Let's create the topic, right? So what I'll do is I'll use the same command, right? And here I'll just provide the partitions as 1, and let's provide the create option. So if you're worried about all the Kafka commands how I'm using, so you can refer to my GitHub repository, right? Here it is. Here I have mentioned all the Kafka commands, right? So if you want to see the topic details, let's see that quickly, right? So the order events, if you see the describe, all the topic description has been mentioned over here, right? So we have the topics created. What I need to do is I can run the consumer application, right? So what I'll do is I'll just run the consumer application. So the consumer application has been started, right? So if you scroll up, and you can see it has printed all the configurations with which it has been started, right? So in our application, we have provided the bootstrap servers as localhost 9092, right? And also we have provided the group ID as the play group, right? So it has considered what all things we have already mentioned. So for example, the auto commit, right? Enable auto commit we have provided as false. So it has taken that also in a consideration. So right, so the consumer application is started. Let's go back to the Kafka console and let's start the producer, right? Kafka console, and let's start the producer, and we need to just provide the bootstrap server, right? And the topic, that's all we need, and let's enter it. And let's say the order 1 is 1 event, right? So if you go to the application, right, so it has been receiving all the values. If you see, the key is null, but the value is there. Why the key is null? Because we are just sending the value. We are not sending any partition key as we earlier demoed, right? So if I add the order 2, it will receive the message, right? If I add order 3, it will receive this message as well, right? It is printing the messages continuously. Let's print out few more messages, right? For example, order 4, right? So it is doing that. Order 5, order 6, order 7, right? So if you see, it is continuously receiving all the orders. This is the very simple Kafka consumer, how it can continuously retrieve the messages. Now let's discuss the role of consumer groups in Kafka consumer, right? So what I'll do for demonstration, let's change this to play group 1, 2, 3, or let's say, yeah, play group 1, 2, 3. So let's say this is my new consumer group, right? Now if I start the consumer application again, now what is the expectation before I'm starting this consumer? So the expectation is we should see all the order events here, whatever we have produced so far, right? So let's do that. Let's see how it behaves. So the consumer application has been started with all the configuration which we have provided, right? So the bootstrap servers. Now if you see the group ID, the play group 1, 2, 3, but if you see, we did not get any of the events. We have all the events, order 1 to 7, right? But this new Kafka consumer does not receive all the events. Why? Because we have discussed this few times already as a part of console consumer. Whenever there is a topic already, and when there are events which are already stored, and there is a new consumer group coming up very first time, it is trying to consume, it will always be getting the latest events. They will not be getting the old messages, right? So if you publish, let's say, the order 10 or order 8, so if you see, now it has started receiving the message. Let's produce one more, order 9. It is receiving the message, right? Now it is receiving all the latest messages, but the old messages it did not receive. If you remember how we have done this in Kafka Console Consumer. In Kafka Console Consumer, we do provide the from beginning option. From beginning. Let me go to the GitHub repository. So this is the kind of Kafka Console Consumer which provide, right? It gives me all the messages, whatever the old messages are also there, right? With this property, we could see all the messages, right? Now let's go back to the consumer application. If you scroll up, you would see the auto offset reset. There is one property, right? So if you see the auto offset reset, this is set to latest. So this is the default behavior, right? So if we change this to earliest, then we started seeing all the messages. Let's do that quickly. Now we are setting the auto offset reset to strategy as earliest. Now let's stop this. Let's start the application again. If you see, it is still not receiving all the messages. It did not print all the events, right? Why it is so? Because it will work for sure, but you have to be patient for like 40 to 45 seconds. There is a reason behind it, and I am going to explain. We will be facing small issues, right? And I will be explaining everything why it is happening. So if you wait for 40 to 45 seconds, already 45 seconds have passed, it will work. So this time it has worked. But why is waiting too long for 40 to 45 seconds? Let's restart and I'll show you what is happening behind the scenes. And if you see the logs, right? So the consumer has subscribed to topic and then it is given one member ID, right? Whenever the consumer is starting up, right? It is given one member ID, right? When we started the consumer last time, the member ID is something different. And this time it is something different because it is randomly generated by the Kafka library and is being assigned to this Kafka consumer, right? Now imagine the case, right? We have already discussed these cases, but our topic has one partition. If we had two partitions, probably we would not see exactly what we are demoing. But what happened here is one partition is already assigned to one member or one consumer group, which was earlier, right? And Kafka broker has already delivered all the events from that partition to that consumer, right? So think of it like this. I'll just show you. Now see this diagram. This diagram is copied from my last videos where we have earlier discussed all the consumer group scaling scenarios, right? So you can imagine this is a topic with three partitions and we already have a service that is a consumer group with three consumers in this group, right? Now in this case, each partition would be assigned to one consumer group, right? Three partitions, three consumers, happy case, right? Now imagine this consumer group dies, right? This is no more. Now what would happen? The Kafka broker has already given all the messages to this consumer group, right? To all the consumers. Now instead of this, let's say the new consumer group is coming up. All right. New consumer group has coming up. So these partitions, because earlier these partitions were assigned to this consumer, right? But now these partitions have to be assigned to this consumer so that the new node should start receiving the message. What happening behind the scenes is Kafka broker checks every 40 to 45 seconds whether all the consumers are active or not, right? If not, then what Kafka does is it does the partition reassignment. So after 45 seconds, what would happen? This Kafka broker or this Kafka broker would attach or would give the partitions to this new node, right? So that's how it is happening. So this partitions would be, one partition would be assigned to this, the other partition would be assigned to this, the other partition would be assigned to this. So the three partitions would be assigned to new three consumers in a different consumer group. That's how it is happening behind the scenes, right? Now the similar case is happening over here as well, right? So if you scroll up in this application, right? So you can see there is one property called session. Let me search that, session.timeout.ms. This is the property which is the kind of heartbeat kind of property. So the consumer would continuously pinging the Kafka broker that okay, I am alive. So if the Kafka broker does not receive the message or the heartbeat in this 45 seconds, it treats that the consumer is no more there. It would do the partition rebalancement or reassignment. So it would do the reassignment or the partition balancing. So after 45 seconds, what is happening? It is assigning this partition to new consumer and delivered all the events. So what we can do in this type of cases? So we have couple of options. If you want to update the session timeout, you can update, but I would say no, don't do that because that's not a production recommendation. Instead of that, what we can do is we can provide the valid member ID, right? So instead of Kafka library creating the member ID, our consumer should have this provision to provide the member ID so that whenever the consumer is sending the message, it would see that okay, the broker would see that okay, that this is the same consumer who is asking for messages, right? So for this, what we can do is we can provide the property as props dot put, and we can provide the consumer config dot group instance ID, right? Group instance ID config, right? So here we can provide the value as, let's say, let's give the value as 1 as of now. Now we have provided the group instance ID as well. Now this time if we will restart, it would work much faster, right? Let's do that quickly. Now the first time, why it is taking much time? Because you can understand that it is spinning up very first time. So for Kafka broker, it is the very first time this consumer is coming up. So this consumer is also treated as a new consumer, right? So that's why it is taking much more time. But after this, whenever you will restart, you would see the faster version of it, right? So even with this version, you could see that it waits for 45 seconds, but let me restart it again one more time. And this time it would see all the messages at the same time. Let's do one more time, right? So let me do this. Now let me clear the console to show you better, right? So what I'll do is I'll just start the main method, and if you see, the messages are coming instantly. Now if you see, the Kafka is giving same messages again and again, right? Because this consumer has already received the messages, right? But why the Kafka is giving the same messages again to same consumer on every restart? If we do let's say if we produce few messages, order 10, it would give the order 10 as well. That's fine. If we give order 11, it would give the order 11 as well. But as and when I am restarting the consumer, it is giving me the old messages as well. But I have already read all the messages, right? So let's discuss that part. Why the Kafka broker delivers the same event again and again to the same consumer? It's mainly because the consumer, once it receives those events, it has to process, it has to tell back to the broker saying that I have processed all the events. It basically has to acknowledge that it has processed all those messages, right? When we were playing with the Kafka console consumer, it was happening behind the scenes for us. So we did not have to do anything. But here we have to explicitly acknowledge the message. So what is acknowledging the message? Why I have to acknowledge? When to acknowledge? When not to acknowledge? Let's discuss that. So if you see, there's a producer, there is a consumer, there's a topic partition, right? So partition maintains the offsets, right? So we do have the current offset, we do have the log end offset, right? So the messages are being stored incrementally, right? So for example, whenever the message is coming, so the offset is being incremented, right? That's how the Kafka is storing the message, right? So when consumer would acknowledge that I have processed the message, for example, I have processed the message till 5, right? So the log end of the current offset would be is equal to 5. The current offset would also move to the based on the acknowledgement, whatever the consumer is sending, right? If the consumer never acknowledges, it will always be 0. But because in this case the consumer never acknowledges the message, so in our case the the current offset is always 0. So it is giving all the messages again and again. So there are few questions, right? So when should I acknowledge? Should I acknowledge first and then processing, or should I process first and then acknowledge? For me, I would say process the message first and then acknowledge. Why it is? Because this is orders event. Let's imagine the real scenario. Somebody places an order, you are in inventory service. So we have deducted the inventory, or we are the payment service. So we have processed the payment. Let's imagine that to process an event, it will take 1 minute to keep things simple, right? So you got the event, you process it, then you acknowledge it. Kafka increases the current offset by 1, right? Now let's say while processing the event, machine crashed due to any XYZ error. Let's say out of memory error, or somebody restarted the server, right? That time you have not acknowledged the message. So because of that, the offset will still be 0. So whenever you restart, the Kafka will again give that event back to you. So I will acknowledge the message once the process is complete, right? So let's do the code changes for the same. In this while loop, right? Whenever we are getting the consumer records from the poll method, right? So what we can do is, if the records is not empty, right? So what we can do is, we can just do the commit operation, right? So the library do provide the commit sync or commit async, but in this case, let's say we want to commit the operation as and when we are getting the records, right? Why we are putting this check? If the records is not empty, they could be we did not get any records because the poll is getting timeout, right? Every 1 second it would be timing out. It could be possible that we get the records, or it could be possible that we don't get the records. So we have to put this if condition, right? So with this, we are just committing the records to the Kafka broker, right? So I'll do the changes quickly and let's start the application. In this case, the offset should be increased, and right, because we are doing the commit sync, right? Now let me publish few more messages, right? For example, order 12, right? So it would receive the message, the order 12, right? Let me publish few more message, the order 13, right? And if we see, the order 13 is also there, right? Now let me restart it again one more time and let's see. Let's restart and let's see whether we are getting all the messages. No, this time we did not get any message. Why? Because we have committed the offset. Now I would like to discuss one more scenario, that is also the production scenario. I'll just show you. What I'll do is, I just want to publish the event and restart the server immediately. I just want to mimic that case. For example, order 14, right? And let me open this, right? And if I publish and if I close, right, now the order 14 has been published, right, and has been received by the consumer, and I immediately stop the consumer application at that time. Now sometimes what happens is, when you restart the application, you might see the event again, right? So probably it has already committed that event, right? So I just want to discuss the case, right? So there is a property called auto commit interval milliseconds, right? So it is 5 seconds set to default. Imagine for an extremely high throughput application, right? You process thousands event in per second, and consumer cannot hit network calls on a TCP connection telling that, hey, I'm acknowledging, right? So it cannot do that repeatedly. So due to which they have optimized this time. If you don't like to acknowledge the message, there is an explicit property, you can use it, that is something called enable auto commit. You can set that is to true. The Kafka would be doing the auto commit behind the scenes for you, right, for the consumer. right? So in consumer config, if this is set to true along with auto commit interval 5 seconds, then as and when the messages are delivered to the consumer, periodically the messages will be committed automatically. So acknowledging means committing the offset, whatever we have consumed. Kafka library is basically committing the message as and when we are doing acknowledgement. But best practice is to acknowledge the message manually, because application knows which message has been processed and which has not been. So that's all I had planned for today. If you enjoyed this video and found it useful, do hit like, subscribe, and please comment on the channel. In the next video, we will be refactoring this code, this very basic consumer application code, to the production level code, how the applications use this consumer behind the scenes. We will see that part, and I will code the producer implementation, and in the later videos I will present the Spring Boot implementation of the same project. So stay tuned. Thanks for watching. See you soon.